In this math counts preparation lesson, we are going to be talking about coordinate bashing, so let's get started. Now, what is coordinate bashing? Now, coordinate bashing, or chord bashing, or chord bash for short, is basically, you might think it's just for coordinate geometry, but it's not. It's for any type of geometry problem. When we have a geometry problem, when we're going to use coordinate bashing, we throw whatever figure we have onto the coordinate plane, assign coordinates, and find lengths using the distance formula, slope of a line, equation of a line, etc. And this is a big part of analytic geometry, which we will talk about in the next video about analytic geometry. But right now we're going to be talking about coordinate bashing, one of the best strategies in geometry problems. Now, coordinate bashing will not work for angle chasing, so it won't work for angle chasing. You can use it for circles. You can use the equation of a circle, right? We can use the equation of a circle. But for math counts, we don't need the equation of a circle, really. Because in math counts, especially like school and chapter, you won't need equation of a circle, but for state and nationals, you will need the equation of a circle. So I will go over that in analytic geometry, but right now, all we need to focus on are the fundamentals of coordinate bashing for math counts. So first off, you need to know some stuff in analytic geometry. You need to know your basic coordinate geometry stuff. First off, you need to know the equation of a line, which I'm pretty sure most people know. This is basically like a prerequisite to math counts, but y equals mx plus b denotes the regular equation of a line. So m is essentially the slope, and b is when the line cuts off the y-axis. If you don't know all this stuff, I recommend learning the fundamentals of pre-algebra and basic analytic geometry. But this video should cover all the basics as well. Y equals mx plus b. So basically, if the slope is 3 and it cuts off at 2, you can just say y equals 2x plus, it cuts off at like 2 or 3. It cuts the y-intercept at 3, or it cuts the y. So essentially, if this is our diagram right now, essentially our line is going to cut through this point at 0, 3. The line's going to cut through this point, and it might go somewhere, and this is not like a definite thing, and the slope is 2, so yeah. So that's basically the equation of a line, an example of the equation of a line. Now let's move on to the slope of a line. The slope of a line is basically, you find the slope of a line by, first off, you take y1, or y2, sorry. So we have y2 minus y1 over x2 minus x1. So basically, if we have, let's say you have some coordinates, we have 4, 3, and a line passes through these 2 points live on the same line, let's say, like 2, 1. So like, we take y2 minus y1. y2 is this y coordinate over here. y1 is this y coordinate over here. Divide it. x2, this x coordinate over here, minus x1, this x coordinate right over here. And now 3 minus 1 minus 3 is just negative, well, 3 minus 1 is 2, and then negative 2 over, same thing over here, we have negative 2, the negatives cancel, we get 1 as of a slope of the line. Now to find the point as which this line cuts off the y-axis, well, we can start with the equation of a line. We can say y equals We already know the slope, x plus b. And now all we need to do is set set x equal to, or like when the line cuts off the y-axis, we need to find out where it goes. So basically, if I have y equals x plus b, right? If we have y equals x plus b, we can plug in stuff, we can find different stuff, find the y when it cuts off the y, find when it cuts off the x. It's pretty slick. Now, over here, we can plug in values. We can say when x is 2, y is 1. So we can say 1 is just, well, when x is 2, right? Remember, you can always like do this to help you out. When x is 2, y is 1, so 1 equals x is 2 plus b. And we can solve for b. 1 minus 2 equals b. Negative 1 equals b. So now we know that it cuts off at negative 1. And now we have our full equation of the line y equals x minus 1. We can plug in values and they're going to all live on that line that we want. Right? That's basically our goal in the problems. Now we can also find when it cuts off the x-axis. So to find out when it cuts off the x-axis, how are we going to do this? Well, when it cuts, we can draw a picture to make this better. Put some marks down here. If it cuts off at, let's say, this point, for whatever point it cuts off, the y-coordinate won't exist. It's going to be 0. So we could just say x minus 1 equals 0, and then say x equals 1, and it cuts off at 1. So those are basically, we have slope equation of a line. Now let's move on to more fundamentals of coordinate bashing. First stuff you need to know: equation of a line, slope of a line, distance formula. The distance formula is by far one of the most useful formulas in analytic geometry. Right, the distance formula states that, well, all we have to do is we take x2, right? We take x2 minus x1. But we're not done there. We square it. And then we add it, right? x2 minus the value of x1. We square the value, right? And then we have y2 minus y1 squared, but we're not done there. We take the square root of this. So we can use an example, a prime example. I'm going to use an easy example. I'm going to start at the origin. I'm going to find the distance 2, 0, 6. Now, I'm pretty sure you know the distance is just 6, but we're going to apply the distance formula to see how it actually works. We x2, this coordinate right here, x1, this coordinate right here, 0 squared is 0, plus y2, just this coordinate right here, y1, this coordinate right here, 36 minus 0 is just 6. 6 squared is 36. Now we have 36. Don't forget, we take the square root of this expression, and this is 6, so it works. We already know the distance is just 6, so distance formula is very useful. Now this is basically all you need to know for coordinate bashing, for you to actually get into coordinate bashing. Now I'm going to supply an example so you can actually work in coordinate bashing. You need to, it takes time to get used to, especially since sometimes it's not clear what to do. Since you have so many tools, we can use distance formula, equation of a line, slope of a line. We can find the slope, find the x. We can do lots of things. We can find area, find like lengths using the distance formula. So the distance formula is probably the most powerful tool here. But we already know everything we need to know. Let's get into the problem. This problem comes from the 2008 MATHCOUNTS School Sprint number 19. We have a right triangle ABC. AB equals 10, AC equals 6, and BC equals 8. Right away, I see a 6 I see a 6, 8, 10 right triangle. So I'm going to first draw out my triangle and label some lengths right away. This is a right angle. This is 6, 8, 10. And AC is 6. BC is 8. And of course, AB is 10. Now we're asked for what is the distance from C to the midpoint of segment AB. The midpoint of segment AB is going to be somewhere around here. It's going to cut this into 5 and 5. And once it cuts this, we want to draw a segment 2-point C right over here. And we want the distance or the length of this segment. I can draw a better one like that. There we go. Now we're trying to find the length. Now we could just go ahead, find, I don't know, similar triangles, isosceles, but that would be, like, it would be a little bit harder. We could use some intuition, but here, we want the distance. We have a right triangle, so it's easy to place onto a coordinate plane. We can always assign this point right here to the vertex, or we can assign this to the origin. And we want the distance. Distance formula, have lengths. This calls for some coordinate bashing. So let's forget all about this diagram. We're going to use some coordinate bashing. I'm going to draw a big diagram. Big diagram, because always want your big diagram. And let's see. This is going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And now over here, this is 6, so all we need to do is put 6 marks. Can actually put one over here, but that's not needed. And let's see. This is actually not needed, so we can just use an eraser on it. There we go. And then obviously we can start labeling some points. So we can assign coordinates, we can assign the right angle portion over here, and then we can assign that over there, and now we can draw a right triangle. See, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And now I can draw a right triangle, and now I can draw the hypotenuse of the right triangle in. And there we go, I'm going to start labeling stuff. So this coordinate is 0, 6. This is 8, 0. And this is obviously just the origin. And we're again trying to find the midpoint when I draw this to this. Now, we already know that this distance is 10. We can break out distance formula, find this, but we can go from here to here. And we're going to find for a midpoint. I'm going to draw the line that we want. The midpoint is somewhere around here. I'm going to find the midpoint of this thing. Once we find the coordinate of the midpoint, all we need to do, we have a plan. Now, we have a plan in this thing. First, we're going to find the midpoint of this hypotenuse using the distance formula, and then we're going to find the distance between the origin and that point that we just found. So that seems like a good plan. Let's go ahead and execute our plan. We're going to find the midpoint. So first we start at the coordinate 0, 6, and we move to 8, 0. So let's see what we're doing. We're increasing the x-coordinate by 8, and we're decreasing the y-coordinate by 6. So I'm going to do half of that. I'm going to increase the x-coordinate by 4, and decrease this by 3. 6 minus 3 is just 3. And we have what we are looking for. We have our midpoint, which is located about here. If we just graph that. Alright, it's located about here. And we have our midpoint. We're looking the distance from here to here. That's what we're looking for, right? Distance from here to here. We can break out the distance formula. We can use a distance formula and use this. So this is basically from the origin to this point 4,3. Now, if you forgot the distance formula, I'm just going to write it over here. Squared plus y2 minus y1 squared. Then we just take the square root of that thing. Okay, square root, that's our distance formula over there. We can use the distance formula. So x2 is this coordinate right over here. We square the coordinate, right? Because in x1 is this coordinate right over here. That's just 4. Square the coordinate, we get 6. Over here we have this y coordinate is 3, and this y coordinate is 0. So 3 minus 0 is just 3. 3 squared is 9. And 16 plus 9 is 25. But don't forget, we have to take the square root of this. So we take the square root of 25. And we get 5. So this distance is just 5. Now let's go back. Distance is 5. Now this sure does look like like isosceles triangles, and we could have used some intuition and figured this out, but coordinate bashing got us a definite answer for sure. It got us to here just by using basic tools.